Hello everyone, we are back here to our webinar on USP 800 on hazardous drugs for healthcare setting. So I'm here with Andy Teague, Jack Simula, and Jeff Spink. So we are talking today a little bit more about the sample, how do we analyze the samples. And so Jeff, so let's recap a little bit what we talked in our last webinar, and so tell everyone that's watching us what they lost or they should remember we talked last time.
Yeah, I think that's a good idea. Thanks, Leandro. Well, today, Jack and I are together here in the conference room at Analytics. Andy's in his office, and what we wanted to focus on today was the analytical process. You may recall that we kind of started out our USP 800 program with an overview of what is USP 800, and I've shown you the number of times the actual document here that I keep telling you we have up on the website. From that we discussed the whole sampling process, how to sample, who can sample, different groups that we can sample with. We talked about the kit. Jack, you went through the kit with everyone. As you recall, we have a free loaner pump program where we can actually send you a pump if you want to do an air sample. But more likely you're going to do wipe sampling, and we provide that wipe sampling kit at no charge. So we discussed that. That was in our webinar number 2. Then we moved into what happens once you do the sampling in the field. Once you do your wipe sample, what happens. And I think Jack did a real nice job reviewing, the process of putting the samples together, getting them in the shipping box, chain of custody, and then sending them off to the laboratory. Jack, you want to touch on that for a minute? Just kind of review that one more time.
Sure, Jeff. Yeah, the last time when we spoke, we were talking about our new sample kits that we have, and these sample kits are completely customizable for each client's needs. And so what you get in the kit is a sample box, as many sample sets as you need, and that's really key when you call in or email in to order your kit. We can put as many sample sets in a box as you want. So one kit for one person is not going to be the same as one kit for the other person because of the number of samples they may collect. A sample set's going to include 2 Tex wipe swabs, a tube to put your swabs in when you're done sampling, a vial of water, and a pair of gloves. And then so you order your sample sets, and each kit will also contain 10 by 10 centimeter templates for if you're doing an area sampling and you want to take a 100 centimeter square area. It will also include a set of sampling instructions and a chain of custody that can hold up to 10 different samples, and a prepaid FedEx shipping label that you would put back on your box, and now your box becomes a shipping box for sending back to the lab. Put that prepaid label on the box and send it back to us. We'll get it the next day. And it's a completely free kit to the customer. There's no cost involved at all on that.
It's really a nice setup. And then what we talked about after that was when the samples arrive, we go to the FedEx station and pick them up every morning around 8:30.
That's correct, yeah.
And that's good because you'll get your notifications from us. We'll be contacting you probably before lunch if when we open your boxes and sample container kits, we find any issues, chain of custody problems or questions or whatever. So, real quickly we'll be able to get a hold of you if we have any questions, because we don't wait for FedEx to deliver them. And Jack then went through the process of receiving the samples, and again, that's all out there in the 3rd webinar. And once you've received the samples and logged them into the system, we then send them over. And Andy, you touched on the preparation process last time, which is again covered in webinar number 3. Which brings us to now, we've received the samples, we've prepped them. They're in solution, as we call it, right, Andy? That's kind of how we term it, right? And whatever was on the surface that you wiped is now in solution, and we need to now analyze that. And so if you could just go through that process, I know it's pretty technically involved, but I think it's really good for us to at least hear it and let the people kind of know about the quality control program. Like, how do we have total assurance that the samples, that what they've sampled for, we can detect that when in the process? I mean, that's the question that gets asked a lot, and kind of how we shoot standards, and we see those, and what goes on from there. Okay. And then go through a little bit the calculation of the results. Because typically we're going to give you a result of like 20 nanograms or something to that effect. And let's just talk about that so the people understand the report. How we prepare and review the report will be helpful. And then, Jack, you can finish up by basically how do we get the report out and what the customer can expect. So with that, I'll kick it over to you, Andy, and you could just kind of talk a little bit about the analytical process.
Okay. So the samples are in solution, and the solution, the dissolution that's applied to your samples, the extraction procedure, has to be mutually compatible. All the compounds you're going to test off of a single sample or pair of swabs, all those compounds have to be compatible or soluble in the same extraction solvent. And that solvent has to be compatible with the instrumentation and the analytical technique that's going to be employed for analysis. That's the reason that sometimes we're going to tell you to collect one sample for this array of drugs, hazardous drugs, HAs, and we're going to tell you to collect a separate sample for this array of hazardous drugs, because we have to have compatibility in the prep and the analytical procedure. So most of the hazardous drugs that we're going to test, other than the platins, we're going to test by liquid chromatography with triple quadrupole mass spec detection. And so before I get into the other aspects of this, let me cover a little bit of what that means for what the triple quadrupole mass spec analysis means. Yeah. So that sample is in solution. You use an autosampler to inject a small portion of the extract into the instrument. The first step is that we're going to use chromatography. It's plain old chromatography that's employed for most of your organic compound analysis, hazardous drug or otherwise. And the chromatography stage is intended to separate out those compounds one from another in the flowing stream of liquid, and have one, thus ideally have one compound at a time be presented to the detection system. This allows the test to be more selective. What hits the instrument, hopefully, is one compound at a time coming through the chromatography system. When that portion of sample makes it into the detector, the first step is a stripping away of the extraction solvent to leave, think of this little cloud of tiny dry particles that are left when you pull away the extraction solvent, and the conditions there also ionize the compound. So you've got this little cloud of ionized particles, and that's before the sample hits the quadrupoles. That cloud of ionized particles hits the first quadrupole. The function there is to manipulate those ionized particles based on their mass charge ratio. The quadrupole is a small environment in which we can control the electromagnetic fields, and you use that to pull out of that little cloud of particles the particles you're not interested in. And So then that little cloud moves through to the next second quadrupole. The second quadrupole ionizes those particles further to give you a bigger array of ions from the parent ion that you started with in quadrupole, that you pass through quadrupole 1. Quadrupole 2 ionizes it into an array of ions. Quadrupole 3 then pulls out of that little cloud of ionized particles the ones that you're not interested in. It allows you to be selective again for which ions you're interested in, and only those ions that you're ultimately interested in hit the detector. The detector is very sensitive, but additionally, all of those stages have made the analysis more and more selective, and that's where a lot of the sensitivity comes from. And that detector then returns a signal, and for your sample, we've previously run on that under those same conditions reference standards of the compounds we're testing, and created a calibration reference for each of those compounds. Oh, and by the way, that process of running through the injection and the quadrupoles, that's repeated, that happens very quickly. And it's happening over and over and over again for each of the compounds of interest that we're going to test from that same injection of a sample into the chromatography and mass spec detection system. So again, that happens lots of times. We can pull out results for many different compounds by running through that process very quickly, one time after another. The instrument was calibrated with reference solutions.
Stop there for just a minute, Andy.
Okay.
Okay, so what we're hearing basically is we've taken the solution that we've prepared from the sample that the client has sent us, and we've injected that into the system using chromatography.
Right.
And what that is a long tubular kind of a long tube that the sample passes through, or to get it into
right. Think of it as a tube packed with particles with an active surface, and the surface of those particles interacts with the compounds as they pass through in solution. As they're washed through, the surface of those particles interacts with the different compounds differently. So some pass through more quickly than others. Therefore, we hope to get one compound at a time passing out of the chromatography system or eluting from the chromatography system.
Right. So now you have one compound exiting this long tube and going into a system where it's charged with electrons, right?
We strip away the solvent so that you can focus on just the compounds that are coming through, and we ionize them. We give them a charge, and so they have a mass as a particle. And again, we've moved from solution down to, think of it as a cloud of ionized particles.
Right.
And they go through the first quadrupole. It pulls out the ionized particles we're not interested in. We'll go to the next quadrupole, and it further ionizes those particles we're interested in.
When you talk about ionization, you're basically taking this compound and you're exploding it, and it's breaking into fragments of different ions.
Yeah, think about, you're ending up with an imbalance in the electronic structure, so that you end up with a particle that has a charge, kind of like a battery that has a charge. And those charges influence how the particle is going to behave in an electromagnetic field. And
Sure.
we're then manipulating that electromagnetic field, that quadrupole detector.
So you're going to actually look, by doing this, your detector is going to look for certain ions that are associated with that.
That are characteristic
Drug.
for that hazardous drug. Yes.
Okay.
And we've already calibrated the instrument by running known concentration solutions.
Yeah, go through that. Go through that. So
Yeah.
you've injected into the system a known quantitation of, let's say, cyclophosphamide.
Yeah, and we've run solutions of known concentration of a high purity drug that we purchased from a vendor, And we use that to create a calibration. We purchase the same drug from a different vendor and use that to make an independent check on our calibration. So that's one of the QC checks that's built in, so that if the purity of one of the reference materials is off, or the identification is off even,
Right.
it gives us a means of identifying that, of recognizing that. So we've determined how, under the given set of conditions, reference standards perform. And then we can take your samples and compare them, how the way they perform, to our reference samples. And therefore, from that, we come away with a concentration measurement for each of the hazardous drugs of interest. And concentration is typically going to be in nanograms. Concentration units will be nanograms per milliliter. We extract the sample in, let's say, 10 milliliters of solvent. And this is your swab sample, or your air sample, but let's stick with swabs. You've extracted in 10 milliliters of solvent, and we've calibrated the instrument down to 1 nanogram per milliliter. Well, that means that we can measure your sample results down to 1 nanogram per milliliter times 10 milliliter extraction means we can measure your sample down to 10 nanograms on the sample. And we have to prove that that works by running samplers that have been loaded with known amounts of the various analytes that we're testing.
And that's only possible to get to that 1 nanogram level by using this technology that we're going through.
Right. Typically you need the mass spec, the quadrupole mass spec, to get to that sensitivity. Now, there's some other compounds that we run using other detection techniques. Liquid chromatography for hazardous drugs there's certain circumstances where other detection techniques are appropriate, and we do have some of those. But the most routine is going to be the HPLC with quadrupole mass spec.
Right.
When we run your samples through, we have prepared known loadings of the compounds that we're testing. We've prepared synthetic samples, QC samples with known loadings of those drugs, and those are extracted and tested alongside your samples in the same sequence of against the same calibration, same set of chemicals, and the same conditions. So that's how we evaluate the success of the process, is with those what we call lab control samples. If you ever talk to us about them, you'll hear them referred to as LCSs.
Right.
But those are known QCs that we use to gauge the success of this process in its entirety.
Now, you've mentioned calibration a couple of times, and I believe what we mean by that is that we inject certain amounts. Again, let's use cyclophosphamide, for example. So we injected maybe 1 nanogram, 10 nanograms, 50 nanograms of cyclophosphamide through the system. We electronically charged it. We got the fragments. We measured it. And so we know that the instrument is giving us a result at these different quantities, correct?
Yeah, think of it this way. Think of the calibration as a mathematical model that represents how the instrument responds to known concentrations of each of these drugs.
Yeah.
And then what we're doing is running your samples under exactly the same conditions and comparing the measurements on the samples to those mathematical models.
Okay.
So that concentration measurement made on your sample in mass per volume units, typically nanograms per milliliter, times milliliters of extraction, gives you a nanogram or mass value for the sample. That mass represents the amount of material that was removed by your surface swabbing. If you tell us the area that you swabbed, let's just say 10 centimeters by 10 centimeters, 100 square centimeters swabbed, we can take that mass measurement and divide it by the area measurement in centimeters squared and return the result for in terms of nanograms per centimeter squared. which is consistent with the example that they give us in USP 800 for assessing, making your contamination assessments.
Okay. So
What's
in
next?
other words, if the quantity that the instrument measured was 50, and they wiped a 10 by 10 square centimeter space, what would the result that we would give them? What would the actual result be then?
All right, think of it this way. I'll fall back to that. We measured in your sample extract 1 nanogram per mil. We extracted it in 10 mils, so that means we measured 10 nanograms off of your sample.
Right.
And you sampled 100 square centimeters, so that's going to be 10 nanograms divided by 100 centimeters squared, and the final surface concentration result is going to be 0.1 nanograms per centimeter squared. And that's how we'd report it on the report. If you give us the, we're going to tell you the mass regardless of whether you give us surface sampled area or not. If you give us the area sample, then we can give you, we can also give you that surface concentration measurement in terms of mass per area. And typically, we're doing this in nanograms per centimeter squared.
Right. So on the report now, we're going to produce the report. What is the client actually going to see on the report? Obviously, they'll get all the information that they provided, the name of the company, their account number, address,
Right.
what time they sample, and so forth. Go through exactly what they're going to see on the report.
Well, they're going to see all the identifiers. They're going to see the record of what surface area sampled they gave us for the sample. They're going to see that indicated. And they're going to see the mass of each of the compounds measured. They're going to also see there's going to be a column on the report that tells how low we could make the measurement. And if the measurement is below that reporting limit value, what's going to show up for the sample measurement is a less than at that level. If we can measure down to 9 nanograms on a sample, then, and the sample measures less than 9, the sample result's going to show up on there under the mass measured as less than 9.
Okay.
We measured at 10, we're going to see that 10 nanogram value reported there. You're still going to see that 9 is our low limit. And then the final result is going to be expressed in terms of nanograms per area, typically nanograms per centimeter squared as a concentration measurement. And that's ultimately that's the value that our typical customer's interested in. We give the other details so that they can verify our results and see the logic of it all. But the surface concentration is typically the end goal. We have some customers that don't provide surface area wiped, and that's fine. It's easier for us. But if you give us the area wiped, we'll work backwards. We'll work the result down to a surface concentration measurement.
So in other words, if I took my wipe from a doorknob, I wouldn't be able to tell you that I had a 10 by 10 centimeter squared surface area. So what I'm hearing is you're going to tell me how many nanograms we detected, the mass of that sample from the doorknob, but you're not going to give me a measurement based on the area.
Not unless you're really good with your calculus and you can work out the surface area. We don't care if it was a flat area, spherical, ellipse, whatever. If you give us an area,
right,
we'll try to turn your mass result, which we're going to report for every sample. We're going to try to match that with a surface concentration measurement. So if you give us an area, we'll turn it into a surface concentration measurement.
And keeping in mind, everyone, that again, USP 800 really is focused on cleanliness of the workplace, making sure that where your employees are working, that it's clean of these hazardous drugs. So if your results come back that you had 13 nanograms, well, you know that you had hazardous drugs present.
If you don't know what the surface area of that doorknob was, but you're getting hits, you at least know that you're getting hits, and
Right.
you need to improve,
know
you need to
have a
improve your
contamination.
housekeeping. And you can
Exactly.
sample that again and see after some period of time and see if the process is the frequency of cleaning, maybe the material you're making it out of, the way people use it. You can see if the processes have improved the circumstance and the measurements lowered.
Yeah. So that's valuable information, just knowing that, yes, there was the material in the sample.
Yeah, and zero, we're never going to report zero anyway. Sample, if we don't get a measurement on, we're going to report as a less than some value that we've demonstrated we can achieve.
Right.
But the goal, I guess the ultimate goal would be for every result to be a less than. But in a lot of cases, that's not going to happen. The goal is to do the monitoring, so you can recognize where your issues are, put your attention there, and bring those numbers down to the lowest value that's practical.
And again, the less than is going to be less than our lowest calibration value.
Well, less than, I won't say strictly calibration, but it's going to be less than at the lowest value that we've demonstrated successful recovery.
Yeah. Okay.
And Jeff,
Okay. So
just to make
now we've produced a report, and the report then gets moved over to final data review area, where they're going to do what with the report versus.
Gotcha. The analyst or a data entry specialist is going to take the data and basically going to interpret the data that the instrument is output, and is going to input into our reporting system those mass values. And if you gave us area values, that's processed into the system when the samples are received. But the data entry person is going to get the results into the system and pass the data and the entries on to a reviewer. That's going to, then the reviewer is going to verify the calibration, all the QC data, but they're focused on the calibration and all the data entry to make sure everything is consistent with the design and that all the data entry is correct. And when they verified all that, they're going to pass it through to the next level of review. Next level review is really what we call as a QC level review. It's focused on an overview of what happened in the first level and the data entry, but with a big focus on evaluation of the QC data that's produced in the set. When those things when that's approved, then the sample is the report is ready for generation. At the point that the report is generated, it gets one additional review for the report as a whole. Those earlier levels of review of data entry and review are somewhat, they're very focused. They look at the report as a whole. They look at the entries and the accuracy of the entries and the testing for one compound at a time. That last level of review is a little more global and looks at the sample result as a whole for all the results, and you can look for consistency or inconsistencies in the reporting. It's a good logic check too.
So the final review, this more global look, is looking at the entire batch of data and looking at how it compares to these specific results.
Yes.
Okay, once that's finished, then the final review process is finished. It's shipped over to
Jack.
Area. And Jack, maybe you could go through what the folks in your area do, the project managers and the people down there, how they handle it from there.
Sure, Jeff. Once the sample batch is going through final review and it passes QC, the status of that batch changes, and then it's put into a queue in our customer service project management area. And everything in that queue is run on a periodic basis throughout the day, and the reports actually print out, and we print them out as PDFs. And the customer service folks that are reviewing the final product, which is they're not necessarily looking at the data and checking QC because that's already been done, but they're looking at any administrative items that have to do with the report. Is there any spelling errors, typos? Did we put the right project name in on the report? And that sort of a thing. And once they've reviewed everything and everything looks good administratively, they'll approve the report to be sent to the customer, and they'll move it to the next queue in our system, where we will send that PDF report along with the chain of custody that accompanied the samples when it first came in, and any other supporting documentation. Like, say, for instance, if there was an email in there somewhere along the way where we had a question about one of your samples that came in, and the customer responded back to us by email, we'll attach that as additional documentation to the report. And this comes in a really nice, neat little package, and then it's sent out to the customer as a PDF by email, and that's it. And customer has his report probably in 90% of the cases, within 3 to 5 days of us receiving the sample, they're going to have a nice shiny report in their email box. And that's it.
And I think what's good about the process is that when the client calls up analytics to order, instead of just ordering online, they actually call in and they talk with the project manager that's going to do that final review. And any thoughts that you might have, like, I'm thinking about doing this, and these are some of my concerns and so forth. All of that is going to get translated into the client service person's data files. And they're going to make notes of what the client maybe was concerned about or thoughts that the client had. So when they do that final review, they're going to be reviewing it with those comments that the client passed on during the ordering of the media, ordering of the collection kits. They're going to review that with those comments in mind, which I think is really powerful, because you've told me something, I've made notes to that fact. Now I'm going to see your final results, and I'm going to take into consideration what you told me during the process of ordering the supplies.
Exactly.
Yeah. So that part, I think, is really strong, and we do that for all of our results, be it USP 800 or in classic industrial hygiene type of work, or environmental work, or when we do dialysis or pharmaceutical, whatever we're doing, we approach it with that mindset, and I think that's it's a really strong aspect of the whole process of how we handle it. So anyway, that kind of completes. And I know we went through a lot of detailed information today, and I welcome you to call back in, and eventually, when we have interactive webinars, we'll be able to answer questions right now online. But please, any questions that you have, or if it's at all confusing, I hope that you will send us an email or give us a call. Anything else, Leandro, that you may have that you want to discuss now with us?
Yes, I want to just touch on the point that when Andy talked a little bit about like not reporting as zero, that's how important is the reporting limit and the technology we have and all the labs should have, because we're talking about nanograms. So it's not any equipment, as Andy told us about the quadruple and mass and mass. It's really important who is contracting this type of services, look at the capacity of their labs or how they perform the testing, because one nanogram, it's not easy reporting limit, Andy, to get. So people should take in this consideration to evaluate their providers. So when look on that.
Yeah, that's well said. I mean, just think of it, Andy, 1 nanogram, the size of that, right?
Yeah, you're talking about a fraction of the tiny fraction of the dot of lead in a pencil, in a pencil period.
Yeah.
Right.
Okay, well, if there's anything else, Jack, Andy, otherwise, I think that'll conclude this 4th webinar. And again, please, let us know if you have any questions and thoughts, and we'll see you in a couple of weeks for our next webinar.
Okay, see everybody. And so if anyone has liked this webinar, just click and like on this video. It's very important for us to keep doing this. And so, and always comment here what you learned and what is good, what you guys learned about this USP 800 process sample analysis. So, and we see everybody on our next webinar.
Thank you, everyone.
Bye.
Thank you.